Hey guys, this is Mr. Grice for Algebra 2 Unit 1.1 Notes, Day 1. Today we're going to be talking about function notation. Our learning targets today are to be able to determine if a relation is a function and to evaluate functions when given a graph. So, a function, or actually we're going to talk about a relation first. So, a relation is not just something you have with your parents, but is also a pairing of values, okay? And when we're talking about pairing of values, we're talking about x comma y, okay? Yeah, that's an ordered pair, all right? So when we're looking at a relation, all right, the two things that you need to know about it is these relations can be finite, okay? Meaning that it's got boundaries, it's set, there's only a couple, or or infinite, right? So when we're looking at our first example, we can specifically see A, B, C, D. It's finite. Those are the ones, the only ones. But then when we're looking at our examples with the lines, okay, infinite. There are tons of them. Okay. Um, so that's what they're kind of talking about. Now, a function, okay, a function is a relation that passes the vertical line test. Okay, the vertical line test states that no 2 points are on the same vertical line. So to think about that, we have our examples on the left right here. If it passes the vertical line test, I can draw a vertical line and it's only going to touch one time. All right, and you want to try to find a spot that makes it false. Okay, so that's true. It passes here. No matter where I draw the line, it's going to pass. Okay. And here I draw my line and see how it hits twice? That means it fails the vertical line test. But you can't be like, oh, Mr. Grice, look, I'm going to draw a line right here and it only touches once. You know, you're right. It only touches once right there. But you want to find a spot that makes it false. Okay? So for our other example, you can't be like, it passes. Did you try right here? Where it hits twice? Okay? So always try to find a spot that's going to make it fail the vertical line test. Because that's going to prove if it's a function or not. All right. Function notation. Okay. Function notation is writing the equation of a function so writing the equation of a function so that the y is replaced with f of x. Okay, so f of x, and the way we say that, which means function of x. Okay, so it's still going to look like y is by itself, the y equal, like for our first example, the relation, here's our relation right here. y equals negative 3x plus 4 is graphed below. Since it is a function, okay, it's a function because it passes the vertical line test, all right, it can be written using function notation. So function notation would be, we take the y, so here's the y right here, and I'm going to replace it with f of x. So this is saying that it's a function, okay, and then it's negative 3 over 2x plus 4, okay? So if you look, this is where the y was, and we just replaced it, okay? So identify two ordered pairs in the function, then we're going to write them using function notation, okay? So I'm going to find an ordered pair. Boom. That's my first one. So that ordered pair is the point 0, 4, okay? And if I'm going to write that using function notation, remember that this is our x and this is our y. I'm going to plug in the x, and when I'm done, I would get y. Okay, so here's my x. Once again, here's my y. F of 0 equals 4. And if you don't believe me, you could plug in 0. We don't have to do this right now. But if you plug in 0 for x, you would get 4 as your answer. Okay? All right, let's find another point. I see the point 2, 1. Okay? So with my point 2, comma 1, we would write that f of 2 equals 1. So once again, we have x and y. I plugged in my x, and I would get y as my answer. Okay? All right, let's look at the next one. So the relation y equals x squared plus 4x plus 7 is graphed below. Since it is a function, okay, well, if it's a function, that means it must pass the vertical line test. It can be written using function notation, okay? So here's our equation. I'm going to replace the y. And something you need to get used to, it's not always going to be f, okay? Sometimes they'll use other letters, and that really doesn't matter, okay? So this one we would say g of x equals x squared plus 4x plus 7, okay? And remember, once again, I replaced the y. So identify two ordered pairs in the function, then write them using function notation. All right, so we're going to see how you guys do. We'll have that be 1 point. That's the point 0, 7. And another point, I can clearly see that guy right there, which is negative 2, positive 3. See if you can pause the video and write those using function notation. Good luck. Okay, so I had g of 0 equals 7, and then f of negative 2 equals 3. Okay, just remember this is our x, that's our y, so this is where the x goes, and that's where the y goes. Okay, go ahead and flip it over. So it's asking us to, when asked to evaluate a function for a given value, you have to find the x or y value that corresponds to it. Okay, So um, let's go ahead and do this. So our function f of negative 3, okay, they're saying this is f of x. So when x is negative 3, what's our answer? So I'm going to find negative 3, okay, and my point right there is negative 3, 0. Okay, remember x and y, okay? So what that means is f of negative 3, because that's our x, it equals 0. And that would be our answer right there. Because we're putting this in function notation. All right, let's move on to the next one. So g of negative 2. All right, so g of negative 2, when x is negative 2, what does y equal? Well, there's our point right there. So that's going to be the point negative 2, 5. So we remember that this is our x and this is our y. So g of negative 2 equals 5. All right, number 3. So when x is 3, here's 3, what does y equal? There's my point, and that's the point 3, negative 2. There's my x, there's my y. So when I write this, we would say that h of 3 equals negative 2. What do you think? Think you got it? Okay, so why don't you try 4, 5, and 6 on your own? Go ahead and pause the video, and good luck. Okay, so k of 0, remember that k of 0, that's our x. Oops, sorry about that. All right, so when x is 0, y was negative 3. So k of 0 equals negative 3. For 5, j of negative 3, so when x is negative 3, y is 8. So j of negative 3 equals 8. Number 6, m of negative 6, so when x is negative 6, we got y is negative 5. Okay, so m of negative 6 equals 5. So here we were trying to find the y value every single time. On the next set, we need to find the x. Okay, so remember that this is our x and this is our y. Okay, so now I'm trying to find when y is negative 6, so I'm looking at negative 6, here it is. What is x? So my point is 4, negative 6. That's my y, so the 4 is my x. So the way we would say this is that k of 4 equals negative 6. So we're just finding that missing piece. 8. When, oh, sorry, find x when y is 2. Okay, so I'm going to go to 2 and boom, there's my point. And that's the point negative 1, 2. X is negative 1, y is 2. So we would write this j of negative 1 equals 2. See if you can do number 9 on your own. Good luck. You're trying to find it when it equals 3. So m of what equals 3? There's my point, and that's the point 0, 3. There's my x, there's my y. So x is 0. Okay, guys, that's it for Algebra 2, Unit 1.1 Notes, Day 1. Your homework is going to be Practice A. Make sure to read the directions, and good luck. Well, this is Mr. Grice signing off for Algebra 2, Unit 1.1 Notes, Day 1. Thanks for watching.